Resource allocation in service delivery is a topic that sparks debate in every management meeting. It's controversial because it directly impacts both customer satisfaction and operational costs, yet most approaches are based on intuition rather than data. Today, you'll learn how OptimizeResourceAllocation uses advanced mathematics to provide precise, actionable recommendations that can transform your service operations. To set the context, let's delve into why resource allocation is so challenging in the service delivery industry. Service environments, whether they're call centers, IT support desks, or field service teams, deal with unpredictable demand. Customers arrive at random intervals, and the time to serve them varies. At quarantadue.ai, every MCP workflow starts from the real tool interface, not from a generic prompt. The goal is simple. Keep the expert in control while the system structures the evidence. Inputs, reasoning, and outputs stay connected in one reviewable flow. Now the results become easier to compare, easier to review, and easier to explain. Traditional methods like fixed schedules or even modern workforce management tools often fail because they can't adapt quickly enough. They rely on historical averages which don't account for real-time fluctuations. This leads to two bad outcomes. Either customers face long wait times, damaging their experience, or resources are underutilized, wasting money. The core issue is the lack of a dynamic system that can balance supply and demand instantaneously. Now let's explore the technical method behind optimized resource allocation. This software is built on queuing theory, a branch of operations research that studies waiting lines. Queuing theory models systems with servers and customers, using parameters like arrival rates and service rates. Optimized resource allocation extends this by incorporating optimization algorithms, specifically linear programming and simulation. These algorithms solve for the best distribution of resources across multiple queues to minimize overall wait time while maximizing resource utilization. Key concepts include Little's Law, which relates wait time to queue length, and the Erlang formula for staffing. The software doesn't just apply these formulas statically, it uses real-time data to continuously update its models. This is a significant departure from common misconceptions, such as thinking that adding more staff always reduces wait times. 4. Allocate for Suez. In reality, improper allocation can lead to diminishing returns. Optimized resource allocation finds the sweet spot. Moving to the software solution, optimized resource allocation integrates with your existing systems to ingest data from sources like ticketing platforms, CRM software, and employee schedules. It establishes baselines for demand patterns and service times. Then, using its algorithms, it calculates optimal resource allocations minute by minute. For instance, if it detects a surge in requests for a particular service queue, it might recommend reassigning agents from a less busy queue. All recommendations are logged with an audit trail, showing the data and calculations that led to each suggestion. This is essential for compliance and review. Additionally, the software offers scenario modeling, allowing you to simulate what-if situations. You can test how changes in demand or staffing would affect wait times and utilization before implementing them in real life. Let me walk you through a hypothetical example to make this concrete. Consider a customer service center with two main queues, billing inquiries and technical support. Billing inquiries tend to spike at the beginning of the month, while technical support requests are more evenly distributed. With optimized resource allocation, the software analyzes real-time data and historical trends. It might recommend having 10 agents on billing and 5 on tech support on the first of the month, then shifting to 7 and 8 as the month progresses. By following these dynamic allocations, the center could reduce average wait times from 20 minutes to 12 minutes and increase agent utilization from 70% to 85%. These are realistic outcomes based on queuing theory principles, not just optimistic claims. On compliance and reporting, optimized resource allocation generates comprehensive reports that are easy for stakeholders to understand. These reports include metrics like average wait time, service level achievement, resource utilization, and cost per transaction. They are formatted to meet regulatory requirements, such as those in industries like healthcare or finance, where audit trails are mandatory. The software ensures that all decisions are documented and justifiable, providing transparency and accountability. In closing, optimized resource allocation offers a scientific, data-driven approach to resource allocation in service delivery. It helps you minimize customer wait times, maximize resource utilization, and make informed decisions. If you're ready to optimize your service operations,